Hello, in this video, I will explain to you on how to solve this problem. Number 7 from Halliday's book. There are two forces in the 2 kg box in the overhead view. Okay, maybe let's write that first. The mass of the box will be 2 kg. Okay, and then but only one force is shown. So there are two forces, but only one is shown. In this one, that will be F1, right? That is shown. And the magnitude is 20 Newton. So I'll have the magnitude of F1 here is 20 Newton. Okay, but we can also write this in unit vector notation, right? Because we need to calculate F2 later, so I will need to write this in unit vector notation. So F1 here, because it's only moving on the x-axis and to the positive direction, we only have the I, right? So I will have F1 in the unit vector notation. I will have 20 Newton on the I direction, like this. And the unit here will be in Newton. And we need to know what is F2, right? So maybe let's name F2 here. Let's name this as X in the I direction, and then plus Y on the J direction. And we need to find out what is X and also what is Y, right? And that is our goal. Good. And then we have the magnitude of the acceleration of the box here is 12 meter over second squared. So let's write that. So we'll have the the magnitude of the acceleration here is 12 meter over second squared. And the direction of the acceleration is 30 degrees. Theta is 30 degrees. However, we have to be very careful here because this 30 degrees is counted from this negative y-axis. To use it in the unit vector notation, we need this angle here. This angle here, right? And this one will be 90 degrees. This one will be 90 degrees. And this one will be 60, right? Because this into this will be 90, but we have 30 degrees here. So I'll have 60 degrees. So if we write it in this green angle here, we will have theta is 90 plus 90. That will be 180 plus 60. That will be 240 degrees. And this is the angle of this acceleration. Good. But I also need to write this acceleration in the unit vector notation. Okay, so we will have the A in unit vector notation here is the magnitude of A here multiplied by the cosine of theta. And this one will be on the I direction, and then plus I will have the magnitude of A, but this time multiplied by the sine of theta, and this one will be on the J direction. Okay, and what is the magnitude of A? So I will have 12, then will be cosine of 240. That will be on the I direction, and also we will have 12 sine. I will have 240 on the J direction. Good. Now let's plug this into calculator. So we will have 12 cosine 240. So we will have minus 6 here, minus 6i. Okay, and then plus we will have what? 12 sine 240. We'll have minus 6 square root of 3, or I will have minus 10.392. Okay, minus 10 point what? 392. Okay, and that will be on the J axis. Good. So now we have the acceleration here in the unit vector notation. Okay, we have two important values here. So let's clean this up and do the real thing. Okay, now remember the Newton's law here. The net force is equal to the mass times acceleration. Good. And what is the net force? We have F1 plus F2, right? So we will have 20 plus x. X is unknown here, so I will have 20 plus x of I. And then I will have plus, we will have the y in the j direction here. Okay, and then what is the mass? I will have 2 kilogram. So I'll have 2, and then I will have the unit vector of A is this one. So I'll have minus 6 minus 10.392. No. The I and j is lost here. So I'll have minus 6i and then minus 10.392. And this one will be on the j direction. Okay. Now let's distribute these two here. So I'll have 20 plus x here, and that will be on the I direction, and then y in the j direction, and we will have minus 12 here on the I direction, and then we will have this one here. Maybe let's use calculator for that. Minus 10.392 times 2. Okay, so we'll have minus 20.784. Minus 20.784. And that will be on the j direction. Good. Now what we need to do is to pair it, right? So I'll have 20 plus x is equal to minus 12. But then on the j direction here, I will have y, and that will equal to this one here. So we can get the value of F2 from this highlighted equation, right? So we will have 20 plus x here. 20 plus x is equal to minus 12. And we can isolate for x. So we'll have x is equal to minus 32. But then we can also get y here directly. So we'll have y is equal to minus 20.784. But x and y is the coefficient of F2 here, right? So we can get the value of F2. And that is the answer for the question A. Okay, let's answer the question A. The F2 in the unit vector notation is this x here, which is minus 32 on the I direction, and then minus 20.784 on the j direction. And the unit here will be in Newton. Good. Now let's answer the question B and C. Okay, to answer question B, we need the magnitude of the force of F2. So we'll have F2, the magnitude. We can just use Pythagorean theorem here, the square root of minus 32 square, and then plus minus 20.784 square, right? And I think nothing that we can do except plug this into calculator. So we'll have the square root of minus 32 and then squared plus minus 20.784 and then squared. Okay, so I'll have 38.16 or 38.157. 38.157, and the unit here will be in Newton. Okay, and then an angle relative to the positive direction. Okay, so I will have the angle of the F2 here, the angle of the F2, that will be the inverse tangent of the y direction. So we'll have minus 20.784 here, and then divided by the x direction, I will have minus 32. Okay, and I think again nothing that we can do except plug this into calculator. Inverse tangent is shift tangent here, and then we will have minus 20.784 divided by minus 32. Good. Now we will have 33 degrees, right? So we'll have 33 degrees. And I think that will be our question. Let's highlight that, our answer for the question. This is the answer for question A, this is the answer for question B, and this one will be the answer for question C. Okay, and I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.